Hey Bram Chemistry Kids, it's Miss Morel, and today we are going to take a look at section 11.2 in the study guide. As a reminder, there are videos that are put in the calendar for you to look at, and those would be a good thing to watch before trying to do this. And also be sure to pop into Google Meet to chat with me and have any of your questions answered. All right, so we're going to start out taking a look at this problem here. Problem number 1. And so we start out by looking at this top problem, and this is going to tell us how to do it. So when we do this, we are essentially trying to cancel out this, and we're trying to get to this. And so in order to do that, we'll just use our mole to mole ratios that we learned about on the previous study guide. So for all of these, we're going to draw a line, and on the bottom, on the denominator, we're going to put the one that we're trying to get rid of. So we're taking this and we want to divide it by something. So we are going to look up here and we have moles of N2O2. So we can see we have it up here. So 2 moles N2O2, and we're trying to get to NaOH. So 4 moles NaOH. So we just look up here at our equation and we use those mole to mole ratios in order to figure out the answer. Next, we are going to look at this one. So we're starting out with N2O2, so we put that on the bottom. And we are trying to get 2 moles of O2. So we can see we have 1 mole of O2, so we just write 1. And then we would go through and calculate these. So our first one, we get 2. This one we get 2.5. Next one, again, we're going to divide by the moles of NaOH. So, because that will cancel out our label, we're trying to get to the Na2O2. So we have 2 of those. Okay, going on. Then we look down here, we have moles of O2, and again, we saw that we only have 1 of those. And we're trying to get to H2O, and we see we have 2 of those. And then here, again, we have 2 moles of these in our equation. And we are trying to get to H2O. So, moles H2O. Then our last problem on this page, we have NaOH. We have 4 moles of that in our equation. And we're trying to get to O2. And if we look at our equation, we have 1 mole of that. Now, we just punch those in our calculator and solve. All right, next page. Now, this page shows us some nice steps, and it shows us an equation and how they found the solution to that. So it goes through some nice steps. You should follow along those. You might want to write those down. Now, it says, in some mole to mass conversions, the number of moles of the known substance is given. In those conversions, which step of the solution is not necessary? No, we always have to start out with a balanced equation. It doesn't help us if we don't. But we don't have to determine the number of moles because we've already been given them. So we can omit step 2 if we're given that information. Then we'll look at our next problem. So our next problem says, in a blast furnace, iron and carbon monoxide are produced from the reaction of iron 3 oxide and carbon. How many grams of iron are formed? So we just write out that equation. So we start out doing that. 2O3 plus 3C yields, and that should just be C. I'm going to go ahead and balance this. I'm going to presume that you guys are comfortable balancing it. And hopefully that will be a good thing. So plus, let's see, plus and so plus carbon. And it forms, how many grams of iron are formed with excess carbon? Okay, so when we do this, and it's carbon monoxide, so it's CO, and so we would need a 3 here in front of this. Okay, now when we solve this, we will go ahead and start out with our 150 grams of Fe2O3, and then we're going to convert that to moles to see how many moles we have of that. So 1 mole of that, we would put the weight in grams down here, so you just add up what 2 irons and 3 oxygens weigh, and so that comes out to 159.7 grams. And so that tells us that we have 0.939 moles of Fe2O3. Now, if we have that many moles, so 0.939 moles of Fe2O3, what that then means is that we need to convert that to moles of iron. So we'll use our mole to mole ratio. So we have 2 moles of iron for every 1 mole of Fe2O3. So that gets rid of the Fe2O3 and gives us how many moles of iron we have. So it leaves us with 1.88 moles of iron. Now we're getting close, but we now have to take these moles of iron and convert them into grams. So 1.88 moles of iron. And then we use our molar mass. So in 1 mole of Fe, we have, oh, that should be on the bottom. 1 mole of Fe, we have 55 grams. So when you calculate that out, it equals 105 grams of Fe. And so that is our answer. So kind of 3 big steps there. All right, last problem. So we're going to start with a balanced equation. So solid sulfur tetrafluoride, so SF4, and water, so plus H2O, yields sulfur dioxide, SO2, and hydrogen fluoride, so plus HF. Now we would need to balance this. I'm going to presume you guys can do that, so I'm just going to write in the coefficients. All right, now we need to do some calculating. So it says that we start with 20 grams of sulfur tetrafluoride. So 20 grams SF4. And if we have 20 grams of SF4, we need to turn that into moles. So 1 mole of SF4 weighs what? And so again, you're going to add up what 1 sulfur and 4 fluorines weigh to get the molar mass. And so that weighs 108.07 grams. So that tells us how many moles we have because we've crossed out grams. And so that leaves 0.185 moles SF4. Now, we have to take our moles of that and use the mole to mole ratio. So we have, oh, I got a little crazy here, 0.185 moles SF4. And we are going to use our mole to mole ratio. So for that, we have 2 moles of H2O, because that's what we want to get to, for every 1 mole of SF4. So we calculate that out, and we get 0.370 moles of H2O. Now we're getting closer. Now we have to convert these moles into grams. So we have 0.370 moles of water. And so we know that in 1 mole of water, so if we add up what 2 hydrogens and 1 oxygen weighs, that's 18.02 grams. And so that comes out to 6.67 grams of water takes place in this reaction. And so that is our final answer. Hopefully that helps you guys. Give me a call, or if you need any help, I'm happy to help. Hope you guys are doing well. Take good care. and wash your hands. Bye, guys.